My name is Borowski. I'm from Panama team, and topic of today presentation is Smells Like Concurrency Spirit, where I describe the attempt to migrate payment loop module to Swift Concurrency. So, quick explanation: what is a payment loop? Payment loop is a module that that enables user to retry payment if for some reason payment fails. Because bleak code was incorrect or card was declined, user is able to retry payment and hopefully pay again. In payment loop, we use Redux architecture, and Redux architecture consists of a couple of elements. There is UI, which emits actions. Actions can be consumed by reducers, which modify the state, and by middlewares. Most of the time, middlewares handle networking calls, but not always, and middlewares can emit their own event. And one important thing, actions are processed on serial dispatch queue, and that means that only one action can be processed at a given time, which will be important later on. So, Swift Concurrency, the brand new API that make rocking in concurrency world much easier. Well, at least it was something that I thought some time ago. I was young and inexperienced in area of Swift concurrency, and I wondered it shouldn't be that hard to migrate payment loop module to Swift concurrency. I mean, we don't use GCD in that many places. It's not that complicated. So if there is any asynchronous code, we can use async and await. We can serialize access to state or serialize calls using actors. We can also connect those two worlds, the synchronous one, the old one, and the brand new asynchronous with tasks. But unfortunately, there was something in the way, and something in the way was a couple of particular problems which I encountered during attempt for migration. And first of all, concurrency breeds concurrency. And what I mean by that is when you use Swift concurrency in one part of the code, it kind of invites all other friends of this method to use it as well. If you make some await call in one method, this method has to be marked async as well, or you have to wrap the code with task. And if you mark the method as async, all the other methods have to await, and maybe they also have to be marked as async. And maybe it's not a particular problem, it's kind of design of API, but it's something to keep in mind with when you consider using Swift concurrency, because usage of this API may spiral out and may lead to many changes in your module. And I mentioned usage of task. Task should work as a kind of connector between synchronous code and asynchronous code. And it should make the life easier, right? Unless there are a couple of problems. And one particular problem is that using tasks can make unit tests more complicated, because unfortunately for now, tasks can be mocked. You can't create some mock task which you inject in your production code, testing code, and you can, let's say, bypass the execution of tasks. If you use tasks, they kind of make your code asynchronous, and it can affect your unit tests. And since there is no way of mocking it, it can make your test fail. And there is workaround for that. You can use XCTestExpectation, and those expectations can be fulfilled. And you can always await for those expectations with some timeout. But as you probably all know, sometimes usage of XCTestExpectation is necessary and it's the only way, but it's also really, really sad, since it makes your testing code much more complicated and harder to investigate. But if we have working production code and our unit tests are finally migrated, now it's time to rock hard with Swift concurrency, right? Unless there is yet another complaint for the Swift concurrency, and it's connected with order of execution. And order of execution is not particularly guaranteed. I mean, it is guaranteed in some cases, but not in the other cases. And let's say you create one task, and you create the task 2, and you create the task 3, and all these tasks are created in single method. In most of the times, maybe in almost all the cases, the tasks will be executed in order. Task 1 as first, task 2 as second, and task 3 as the last one. But it's not guaranteed, and it's possible that those tasks will be executed in different order. And when can it lead to problems? Let's say you have architecture which relies on executing some actions or some calls in very particular order. And previously, we could serialize the execution of those actions with work dispatcher. And just to be concrete, the work dispatcher is really just serial dispatch queue, which enables for enforcing that only one action is processed at given time. And let's say we figured out that we want to migrate to Swift concurrency, we want to use actors, and we want to dispatch tasks. And in such cases, unfortunately, order of execution is not always guaranteed. I tested this code in, let's say, the migrated code, and it seemed that it worked okay. But I found on the internet that some people reported issues in production code, that for some users, the order of execution of tasks is different than they expected, and there is workaround for that. But it's unfortunately really complicated, and maybe your application doesn't need very particular order of execution, but if it do, and if you migrate to Swift concurrency, the result can be, let's say, surprising. So wrapping up, what is my lesson from using Swift concurrency? Well, to be honest, I stay away from it. Well, at least for now. I don't want to say that it's a bad tool and you shouldn't use it. You definitely should consider using it basing on your domain and on your very particular use cases. But from my point of view, it brought more problems that it solved, and it kind of made code much more complicated. And the main takeaway I would like you, to leave you with is that if you're not using Swift concurrency for now, or for some reason you can't use it and you have to stick with GCD, with Grand Central Dispatch, maybe there's nothing wrong with that. Maybe it's a good thing, because GCD is seasoned and well-tested API, and you can really achieve a lot of very complicated computation using this tool. And that would be it. Thank you very much.
Thanks, Jan. I'm not sure if you are still there because I cannot see you, but oh yes, you are. Yeah. So there is no time for question. Just please visit the Slack channel and answer them if there are any.